these notes are going to introduce big O. So the primary way to measure the efficiency of an algorithm is the number of steps that it takes. And this is surprising if you consider the fact that certain steps take a different amount of time. And you'd imagine that the time an algorithm would take would be the primary priority of somebody measuring the efficiency of an algorithm. But that isn't the case. If the third step is 1 second and the second step is 2 seconds, they're both counted exactly the same. All right. So how would we describe the number of steps a linear search takes relative to the number of pieces of data that the array contains, so the number of elements in an array? You would say for every n elements, there are n steps, because you have to search through every element, and each search is a step. Now, this statement is kind of wordy when it can be expressed with just a little bit of notation. So if somebody writes O of n, that is exactly equivalent to this phrase. All right, and all steps are assumed to be, well, that's not true. No, that's not true. All right, the other thing I want to go into is the ways to pronounce O of n. You could say, writing O of n, you read this as order of n, or just O of n, like I just did. All right, and then if there's operations that you need to do that only take one step, like let's say inserting at the end of an array, then you'd write this as O of 1, because this always takes one step, or order of 1. And that's all I can remember about that.